The fundamental reason I'm interested in odor memory is because it's a model for memory overall. Memory is obviously important. We use our memories to make our way through the world. They also make up an important part of our identity.
Before we go any further, just take a breath. Not a deep one, not a dramatic one, just a normal breath. Because inside that breath, right now, are thousands of invisible molecules drifting, colliding, entering your nose, triggering signals your brain is already trying to understand, but you don't notice it. Your brain does, but you don't. And before you realize it, your brain has already turned that breath into something meaningful. Welcome to Sense Making from the Monell Center in Philadelphia. At Monell, scientists study the senses, how we smell, how we taste, and how those invisible signals shape the way we experience the world. Because smell isn't just about what's in the air. It's about how the brain interprets it, how it guides decisions, how it connects to memory and to emotion. Each sense-making, we start with a simple problem, something familiar, something you think you understand, and then we're going to take it apart, layer by layer, until what once seemed obvious becomes something new. This episode begins with a question. Why does spring smell like spring? There's a moment every year when the air changes. It's not warmer, it's not brighter, it's just different. You step outside and something stops you, not visually or consciously. You pause, maybe without even realizing it, and then you take a breath. And in that breath, something clicks. And then almost without thinking, you breathe again. And this time, you recognize something. It's the smell of spring. It's immediate, instinctive, recognizable. There is no analysis. You don't question it, you just know reflexively. But what's happening here? There is no single smell of spring, no spring molecule, no single chemical signature. So what you're actually smelling is a chaotic, shifting mixture of wet soil releasing compounds after months of cold, plants producing volatile molecules as they grow, microbes waking up and changing the chemistry of the ground. Thousands of molecules drifting in constantly changing combination with moisture, airflow, and temperature all changing how these odor molecules move. Spring isn't just one smell, it's thousands. And yet, your brain compresses all of that information into one experience, into one word: spring. But how? How does your brain take thousands of invisible signals and turn them into something so familiar, so emotional, and so immediate? How does chemistry become meaning? Why does spring smell like spring? The solution to our mystery isn't just what we're smelling. It's not just the stimuli floating in the air. It's how your brain interprets those thousands of signals into something singular and meaningful. That is, the answer isn't just in the air. It's not just out there waiting and forcing us to respond to it. It's how our brains interact with the spring air and the memories and emotions that are evoked from experience. In today's sense-making, we're going to explore the mystery of the smell of spring in 3 layers. First, we'll try to understand odors, the signal that we receive. An important component to the smell of spring is the fleeting nature of smells. Yes, these mercurial molecules can be manipulated, controlled, and studied. We'll look at the work of Joel Mainland's lab, who have developed a new odor delivery system for testing human smell. The Mainland lab is trying to control and standardize odor stimuli for testing in research. Second, odors and the brain. The brain is the processor of the signal, and our brain is constantly building meaning from invisible chemical signals in the air. When we smell something, the meaning of the smell of spring is built from our memories and emotions evoked in the brain as a response to the spring air. We'll hear from Dr. Kevin Boulding, who started his career here at Monell, and he studies odor memories, hoping to map in the brain the experience of detecting a novel odor, which is the very building block for an odor memory. Finally, after we've looked at the signal, after we've looked at the processor, we'll look at the response. Smell doesn't just tell you what's there, it shapes how you feel about it. There's a strong connection between smells, emotions, and mental health, such that our mental state benefits from the good mood provided by pleasant odors, like the kind you find in spring air. Doctors Valentina Parma and Pamela Dalton are quoted in a recent Time magazine article titled, "Why You Should Stop and Smell a Flower for Just 30 Seconds." The article talks about the influence of smell on our emotions and memories. Doctors Parma and Dalton provide the real-world impact of the basic science done by researchers like Drs. Mainland and Boulding. Together, these three layers turn chemistry into understanding. And that's why spring doesn't just have a smell, it is a sensory experience.
I actually do a lot of gardening in the spring, and when I start digging in the earth, it's not necessarily the smell of the flowers that makes me feel like it's spring. It's all those organic materials that are in the dirt that I haven't smelled since last September when I put the garden to bed. That brings back, okay, it's time for revival, regeneration, renewal. And it's very, very, very powerful, much more so than even the smell of the plants that I'm putting in.
Once control is established, researchers can begin to separate two things that are usually inseparable: the stimulus and the perception. The fleeting nature of smells is a problem for scientists. It's one of the central challenges to olfactory research, because smell is inherently unstable. Capturing a smell isn't the same as capturing an image or recording a video or audio file. You can't press play on a smell. Odor molecules drift, they mix with the air, they degrade over time. In testing smell, even small changes in concentration can have drastic effects on perception, which means that without precise control, you can't be sure what someone is actually smelling. So, if smell is so ephemeral, how do we study it scientifically? How do we isolate it? How do we measure it? How do we control it? Because if you can't control an odor, you can't measure it. And if you can't measure an odor, then you can't be sure what stimulus you're presenting. That is, if you can't control the stimulus, you can't trust the results. The perception of smell is triggered when an odor molecule binds to a receptor in the nose, sending a signal to the brain.
We have these physical molecules coming into our nose and matching up with our olfactory receptors and triggering a sensation. That is essentially the physiological system, the hardware that allows us to smell. And everyone is wired a little bit differently. But we're also probably even more differently wired at the software, the cognition, what we interpret those smells coming in. And that's interpreted based on our experiences. And those experiences could go all the way back to infancy in some cases, right? And so we have two different sources of input and two different sources of variation. What we can smell and how that molecule is represented in the brain, and then how the brain takes that information and interprets it. Is it good? Is it bad? Is it something I want to continue to smell? Do I want to eat it? Do I want to put it on my body? Do I want to get it away from me? Yeah.
An odor molecule, or odorant, is just a small chemical compound that can evaporate into the air and enter the nose. Once in the nose, it binds to a specialized receptor and initiates a neural signal that the brain interprets as smell. Not all molecules can do this. An odorant must be sufficiently volatile to reach the nasal cavity, soluble enough to interact with the mucus lining, and have a molecular structure that fits and activates specific olfactory receptors.
An odor's ability to trigger perception is influenced by several factors. The concentration, because higher concentrations generally produce stronger perceived intensity. Also, the stability and delivery of that concentration, and the specific receptor interactions it produces in the brain. The brain shapes perception, learning, memory, prior experience. These are all influencing how odor signals are interpreted, meaning that smell is not just a property of a molecule, but a constructed sensory experience. But for now, let's stick to the plan and just talk about the odor stimulus. For over a century, scientists have been attempting to measure smell with widely different results. I mean, they're looking at the same molecule, they're asking the same question, but it's different labs using different techniques and totally different results sometimes. Why? Because smells don't behave. They won't sit still. They drift and they stick and they dissolve. They change depending on the container, the air, even the room that you're testing in. So, how do you study something that doesn't stay still?
At the Monell Center, new research is showing that the answer might be a bag. Not a high-tech machine, not $1 million instrument, a bag. Researchers in Joel Mainland's lab have developed a new odor delivery system using something called a nalofan sampling bag.
So these are basically bags filled, so if you take a sniff of a jar, you draw room air in when you smell it, and so it dilutes it, but if you fill the bag with a known amount and then you suck through a mask, you get exactly the odor that you want.
Traditionally, using liquid dilutions of odorants is a standard way of preparing odor stimuli. These liquid dilutions are placed in bottles or jars or added to delivery systems that are meant to be used several times across many participants. But these methods lack the real-world experience of smelling odors as they travel in the air naturally. Also, with each trial, there's a concentration shift such that the stimulus is degrading a tiny bit each trial so that concentrations may be quite different between the first participant tested and the 20th participant tested on the same dilution series.
Instead of dissolving odors in liquid, the Mainland lab lets them exist in air inside a sealed space, a sealed pocket of odor, so to speak. Using specialized sampling bags and sealed environments, the Mainland lab can create precise concentrations of odor molecules and deliver them consistently.
No contamination, no dilution, no variability from the surrounding air. Inside the sealed bags, the odor remains remarkably stable. In testing, the bags produced stronger signals, clearer differences between smells, and most importantly, reliability. This might sound like a technical detail, but consistency of a stimulus is foundational to research. And smell begins with chemistry, because before you can understand how the brain interprets smells, you have to know exactly what the brain is receiving.
Once that control is established, researchers can begin to separate two things that are usually inseparable: the stimulus and the perception. Not just what are we smelling, but how does the brain turn that into experience? Our current state of being is influenced by what we smell, what we remember, and how our brain interprets the world around us. At the Monell Center, neuroscientist Kevin Boulding studies something deceptively simple: how smells become memories.
So I'm Kevin Bolding. I'm a faculty member at Monell, and I run a neuroscience lab. We study how the brain represents odors, how those odor representations acquire meaning, and then how those representations are formed through learning over time. And we combine behavior with large-scale neural population recordings and analysis to try to understand how those neural representations actually guide adaptive behavior.
That word, meaning, is doing a lot of work here. Because smell isn't just a signal. It becomes something through experience. And in Dr. Bolding's lab, smell is a model for something much bigger.
The fundamental reason I'm interested in odor memory is because it's a model for memory overall. Memory is obviously important. We use our memories to make our way through the world. They also make up an important part of our identity.
That smell of spring likely connects you directly to systems in your brain involved in memory and emotion. That connection is what makes smell so powerful. That's what makes smell different. A sound can remind you of something. A photograph can help you recall a moment, but smell can bring you back into that moment instantly.
A baseball field in April, rain on pavement, fresh cut grass, a garden, your father's jacket.
Because when you smell, you're not just detecting something, you're remembering. Even if you don't realize it, your brain does.
If you want to know about odor memory in particular, of course you need odor memory to decide what to eat, to run away from a fire, all these basic things that you need to survive and be fit in the world.
Your brain is constantly comparing incoming signals to patterns it has learned over time. Every experience you've ever had with a smell, every spring, every rainy day, every outdoor moment, becomes part of a larger system. A system that allows your brain to recognize patterns quickly. Over time, those patterns become compressed, simplified, abstracted into categories.
Animals can learn about odors very quickly, and it's possible to record and observe neural population activity during that learning process. Over time, the type of work has become more and more focused on memory, how odor memory representations are formed, and how they're retrieved and used by the animal.
Your brain is constantly updating these representations, refining them, strengthening connections between certain smells and certain meanings.
Spring becomes one of those meanings. Not a specific smell, but a learned pattern.
And smell memories aren't static. They're learned, they're updated, and they're reinforced. So when you take that step outside in early spring and you take a breath, your brain doesn't analyze each molecule individually. It recognizes a pattern, and that pattern carries meaning. It signals change. It signals growth. It signals that something in the environment has shifted.
So every spring you've ever experienced, your brain has been building a memory model. It's layering places and people, moments and feelings onto the same invisible molecules until eventually wet earth and warm air stop being molecules and start becoming spring. It's not a smell, it's a meaning. When we retrieve these memories, we're not just recalling a moment, we're recalling a state of being.
And our current state of being is influenced by what we smell, what we remember, and how our brain interprets the world around us. Our environment is shaping our mental health every day through our senses. A recent article in Time magazine argues that smell is an under-recognized pathway into mental health, with implications for anxiety regulation, trauma triggers, emotional resilience, and just everyday well-being. The article highlights research from Monell scientists Valentina Parma and Pamela Dalton.
Dr. Valentina Parma emphasizes the idea that smell is not just sensory, It's deeply tied to emotions and memory, shaping how people experience their environment and their own internal state.
So smell can affect memory and emotion a lot, and partly because the olfactory areas and the emotional areas and the memory areas in the brain are very much overlapping. And so this is not by chance that when you smell something, you're generally like time transported in a place and time that it's not the current one, and that could be very vividly related to good things or bad things.
Dr. Pamela Dalton focuses on how odors can modulate stress, attention, and perception, showing that smells can either calm or heighten anxiety, depending on context and individual experience.
I think the way I interpret that title is that we don't consciously pay enough attention to how our sense of smell informs our well-being. And so rather than just passively moving through the world and letting the odors waft over us, take some time to actually think about what you're smelling. Think about how it makes you feel and whether you want to have that smell in your life.
Smell goes straight to brain areas involved in emotions and memories. When you smell something, you're not just detecting it, you're feeling it.
I think that people underestimate not only the human ability to smell, but the power of how smell can move us. And I think that's because when we smell something, we don't necessarily consciously identify what we're smelling, but we have this incredible shift in our mood. We might be very much happier, much more relaxed, or it might actually make us very angry or very hostile.
But, it is true that odors are able to change like the predisposition, the behavior, the psychophysiology of a person, like the emotional state, even if we think about body odors. So there is some ability for the odor, especially when a situation is ambiguous, to introduce itself and color the situation with a positive or negative valence. But it might not be universal for everybody and for the same person at different points in time. So complex.
And that's where spring becomes powerful, because spring smells are tied to your childhood. They're tied to routines. They're tied to yearly seasonal changes. And Dr. Pamela Dalton focuses on how odors can modulate stress, attention, and perception, showing that smells can either calm or heighten anxiety, depending on context and individual experience. The same smell, fresh-cut grass, rain, flowers, can have different effects on different people. It could calm one person and unsettle another, because smell is never just a chemical. It's personal.
That type of blanket statements related to one odor, in my opinion, are really hard to be met because of the variation, genetic and environmental, that I have described above. Like we're very different, and so we might find odors that in the vast majority of people will be considered either positive or negative, and it could be relaxing or not, but this is definitely not a universal.
We're all existing in our own sensory worlds. And now is a good time to point out that May is Mental Health Awareness Month. When we talk about mental health, we usually talk about therapy or meditation or medication or mindfulness, right? But this research suggests that there's another layer, a silent one, your environment. Your daily sensory world. This is constantly shaping your experience, and smell is one of the most powerful parts of that.
Pay attention to odor is my first advice, and second, expose yourself to odors, because we know that sometimes there are odors we cannot smell very well, but if we repeatedly expose ourselves to them, we can actually start doing that. And better olfactory ability seems to be related to better sense of well-being, less depression. And so let's consider like the nose a channel to even improve our emotional experience in a positive way.
So when spring arrives and everything smells different, you're not just experiencing the season changing or new odors. For some, this is renewal. For some, optimism. For some, it's nostalgia. Memories are being reactivated. Emotions are being recalibrated. Your sensory experience is affecting your mental state. So that moment when you step outside and something feels different, it's not in your head. Well, actually it is in your head, but it's your brain responding to the environment around you.
Our environment is shaping our mental health every day through our senses. So go back to that moment. You step outside, the air feels different. You take a breath. And you recognize it instantly. It's spring. But now, maybe that moment looks different because you understand what's behind it.
We asked a simple question. Why does spring smell like spring? Now we can answer it.
Spring smells like spring because of 3 connected systems. There's the stimulus. In the spring, we get a new palette of odor molecules, and the warm air and changes in humidity make odors more available to our noses for detection. There's the processor, which is our brain. Our brain's constantly translating invisible chemical signals into meaning. Not just detecting molecules, but organizing them into recognizable patterns. That's why a complex mixture becomes a single idea. Spring. And then finally, there's the response. Smell is directly connected to emotions and memory. Not metaphorically, biologically. Smells shape behavior and mood. So, why does spring smell like spring? Thousands of molecules are interacting with our sensory system. We have a brain that has spent years learning patterns and building meaning. And we have emotional and memory systems shaping perceptions in real time. All of this is happening in an instant. All of it's invisible. And all of it is essential to how you experience the world. So when you smell spring, you're smelling your brain sense-making in real time. On behalf of the Monell Center, this is Christopher Mowdy. Thank you for listening to Sense Making.